Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome back to NPTEL online course on logistics and supply chain management. I am Dr. Vikas Thakur, Assistant Professor, Department of Humanities and Social Sciences, IIT Kharagpur. So now today we will talk about supply chain models and modeling system. We will see what are the different options we have when we will define the overall layout for the supply chain, and then we will model all those scenarios, and we will see what are the results of the simulation if we will go with one particular type of model, and then how we can adjust all those parameters so that we can come up with the desired output, whatever is the requirement by the customer. Either customer is maybe more cost focused, or maybe a customer wants a responsive kind of delivery. So those parameters we will see, right. So this modeling system will help us to model all those requirements of the customers. Will also consider the constraints from the supply chain side, right. Whatever the capabilities of our supply chain, we will also consider that. All the stakeholders will take into picture, and then we will see this is what maximum we can do using that particular approach, right. So this is how we will proceed for this. We will just introduce about the supply chain modeling, what are different components we will consider when we will go for the modeling process, and then we will talk about some supply chain models, and obviously we will talk about the future in this modeling system, right, and we will end up with some cases, right. So supply chain modeling, designing and analyzing a supply chain to identify potential improvements, right. So that means it is a kind of design of experiment approach, where we will see we will try different types of inputs, right, and in different quantities, right. This is how you initially how you are learning the cooking process, same way, right. So sometimes you are adding some ingredient maybe in more quantity, so then you will suddenly, after analyzing the output, tasting that food, you will realize, okay, I need to reduce the quantity of that particular ingredient, or maybe I need to increase that. So in that way we can simulate different scenarios just to will find out what are the outputs, whether the outputs are efficient the way we want that system should behave, right. So we can compare with the whatever pre-assumptions we have about that model. So either we can talk about the offline model, static, or we can go for online model. This is known as offline model. This is known as online model. Offline means we will take care of the present scenario and we will model the factors likewise, right. We will consider all the situations, whatever is right now, we will record the data on that, and on that basis we will run our model, and we will say this is going to be the output if we will go with this approach, right. Dynamic model is a kind of model which continuously feeds data inside the system, and then is there any changes in the environment, that also we can reflect on that. So it is a kind of we call it online system as well. And then we can go for the Monte Carlo simulation models, where we can talk about different scenarios, and those scenarios, if we will go by one way, what will be the output, and if we will go by other way, what will be the output, and chances of happening that particular thing, we can figure out all those things, right. So talking about either local supply chain or global supply chain, right. So we have so many different stakeholders, we have so many different processes, different activities, so many different products we are handling through the same supply chain, right. If raw material is there, that is different product, finished good is different product, after returning back that packaging is another different product, right, or maybe after the end of life we are handling another kind of product which requires altogether another set of activities to perform that, right. And in that way so many different organizations are involved. So
like we have raw material suppliers, we have manufacturers, we have co-manufacturers, we have distributors, we have warehousing partners, and then end mile delivery partners are also there. So, all those things we can model in this system, right. So, any miscalculation will, you know, you will end up with the in the scenario where you will be facing more risk, uncertainties will be there, because you could not figure out the, you know, dynamic environment in that way, and then interruptions to your smooth supplies, and then obviously when you are, you know, reacting here and there, you are trying to somehow manage the things, your cost will be higher on that side, because you are not, you know, standardizing the process. So, that will lead to extra cost. So, then after replicating all the scenarios within your model or in different models, you can pick the most suitable supply chain model. That depends upon whether that most suitable supply chain model for one may be it is cost efficient, and for other may be it is responsive kind of model, which is, you know, responding so quickly to customer requirements that you are changing those things. So, depending upon the different choices, we can then come up with the final model. Either your supply chain now is cost efficient, or you are lying toward the responsive side, right. So, these two ends are there, either you can be cost efficient or you can be responsive. But yes, we as supply chain, you know, managers or whatever organizations are working, we are not purely saying that we are only cost efficient, we will not take care of any kind of input which is coming, maybe in terms of quality, maybe in terms of quantity, maybe in terms of variety you are putting to us. So, that we will not say, right. So, yes, somewhere we will find out the mixture, okay, this particular product requires most maybe cost efficient supply chain, will somewhere set the parameter here, maybe this requires a kind of emergency services, healthcare services, we can set up our parameters somewhere here, right. So, obviously the ultimate purpose is to reduce the cost, increase the efficiency and customer satisfaction within that particular target area where we are saying that either we are responsive or we are cost efficient. So, when you need to model these different supply chain scenarios, obviously you need to define what are the components, right, how those components will change here and there, so that the final outcome will change. So, let us talk about from the very beginning point, like procurement. So, now procurement, again different different scenarios are there, we have multiple vendors or we have single vendors, right, and then how many components we are outsourcing, right. So, that means procurement, then how many lots in 1 month you are procuring, then what is the lot size, right. This lot size will help you to negotiate on your price as well, right. So, these all parameters are there. When you will consider the model, you will consider all these inputs, because if you increase the lot size, this is what Walmart is doing, always feeding very large orders to their suppliers, so that they can negotiate on the your price, right. So, and then they can maintain the that minimum quality level as well, because this procurement, now your raw material suppliers, they need not to go so quickly for changeover, because if you are buying product in small lots, maybe then from one lot they are preparing for 50,000 items, then they are changing over to next lot, maybe for 30,000 they will prepare, then 35,000. But instead of that, maybe if you are uniformly you are doing that, you are producing one item 75k units, and then you are changing over for the next model, right. So, then in that way your suppliers will also be in that way efficient, and you can further reduce the pricing. So, this is again one important component which you can consider. Second, manufacturing, where the manufacturing is happening, right. What are the different locations? Are you going to provide the are you going to serve the different market from different locations, or maybe one centralized facility manufacturing hub will be there, and then you will be circulating throughout the Indian market? That can be the another scenario. That depends upon the initial investment cost of setting up any manufacturing unit, right. So, then how much of one particular model you will, if you are having 4 or 5 different production lines, so this is producing A and B model, here we are producing C, D and E model. So when you will go for changeover, right? So that optimal level you can decide that if I will run this particular production line for 10 hours continuously, that much is going to be the productivity, because whenever we are going for changeover in the process, initial time we are taking to set up, to standardize that, and then we can produce some rejection as well. So those factors we will consider. Third is warehouse. Now we have two different scenario. One is we are putting this warehouse very near to the customer or maybe markets. These are n markets are there and warehouse is very near. So quickly you can respond to the customer, right? So that means you can reduce this distance, outbound logistics distance to the customer, to the market, and then quickly you can respond. If this warehouse is a kind of centralized facility which is far away from your main markets, maybe the distance is higher in that case. So then obviously if you are serving to market 1 or market 4, so then that much distance you are covering, right? Because why you are doing that? Because you don't want to set up so many different warehouses at different locations. If instead of going for 1, 2, 3 different warehouses to serve these 10 markets, you are maybe keeping inventory at 3 different locations. But when I am having centralized warehouse, I am keeping inventory here only and serving all 10 markets from the centralized location. In that way we can minimize the inventory cost, but you need to take care about the transportation cost, because then from central facility every time the order is coming from the different market, you are moving to that particular location. So in that way maybe economies of scale you also cannot utilize fully, you cannot fully utilize the container vehicle capacity as well, right? Transportation, as this is related to this structure only, I told you if we talk about compare the inbound logistics cost with the outbound logistics cost, so your outbound logistic cost is always higher. That means you want your warehouse should be very near to your end market, because this distance if you are covering maybe 100 kilometer and if this is 5 kilometer, so outbound logistic cost is higher. We discussed in another session why this outbound logistic cost is higher, right? And if you are following this particular model, for every market you are maybe covering a distance of 35 kilometer, 40 kilometer, 30 kilometer, 25 kilometer. So that means outbound logistics distance is now increasing, right? So in that way, so this is, if you will take example, if you are buying furniture from Amazon, Flipkart, so they are disassembling that furniture and that it is reaching to your doorstep and again you are assembling that. So this is one way, because when you will buy the raw material or you will disassemble the product, it is easy to carry that product from one end to other end. The other example maybe if you are carrying maybe of these cars in one container, maybe 8 or 10 maximum car you can ship if that size is little small of the car, right? So but if you are carrying the raw material component, you just imagine within 10 containers how much raw material you can transport. So that means if your factory is near to the end market, then that outbound logistics cost can be reduced. But yes, then again other challenges are also there when you are moving near to market. So that means you cannot operate with one facility. For many markets you need to come up with many manufacturing units, right? So that way it will increase that cost. So somewhere in your modeling system you need to put all these parameters, and for a particular product you are depending upon the nature of the product, size of the product, how frequently you are shipping, demand from the market, how quickly you are changing that product. All those parameters will consider in that model and will come with the best fit model, which will tell you about all these parameters, 8 components, how you can set, where you should develop your warehouses, where you should set your manufacturing unit, which kind of transportation mode you should use. Now this is the next parameter. Fourth one is transportation. We talk about different modes of transportation, either through road, through rail, through air, through ship, right? But yes, all those parameters are there, that if you will go by ship, the least cost method maybe, and sustainability also will take care. If we'll go by road, it is taking more time. If we'll go by air, it is very speedy delivery, but yes, in that way your cost is increasing, right? So all those factors also you will consider. Availability of the infrastructure, you can use ship only when the infrastructure is there, right? You can use air facility only when that infrastructure is there, but for specific products maybe you can go for that kind of infrastructure, right? So fifth one is inventory. Already we discussed, we are maintaining three different types of inventory, either raw material or semi finished good or finished goods, and some rejected also we are maintaining the inventory in the hope that we will repair these products and again we will resell in the secondary market or in the same market, or somewhere recycling, remanufacturing can be ensured, right? So now if you are, again we will take that scenario only when we are keeping our warehouse very near to the your markets. So that means now you are going with the multiple warehouses for one, for maybe this market, these 10 markets you are serving by warehouse 1. We have warehouse 2 which is again serving maybe another 20 markets. We have warehouse 3 which is again serving maybe another 20-25 markets, right? So that means if we are moving very near to customer, we have multiple warehouses. So that means that will increase the cost of keeping the inventory, because every warehouse you will keep the inventory. That's why online platform when we are going, so now because they are opting for zero inventory model, it's not inventory led model, where earlier they were taking the inventory from the manufacturers, from the sellers, and they were storing in their warehouses, and whenever Amazon is receiving the order, they were processing that order. But now what is happening, they are not keeping inventory in that way, minimizing the inventory cost and directly channelizing the product from the seller to the customer, right? So then you can save the inventory cost. So these factors we will consider, because obviously when you will model these factors, you will ensure that you are not stock out, and also you are not keeping excess inventory with you. That these 2 points you need to keep in mind, right? Then information technology, this is a kind of your component which will affect your all the players, all the activities in that supply chain network. So you need quick relevant information, transparency should be there. Where is the material right now, right? How much quantity coming, how much maybe units damaged during transportation, during handling, how many are finally consumed in the production floor, how many finally consumed in the end market, consumed by the customer. So then this information technology, what type of system you are implementing to ensure the quick information sharing system. Then again customer service is another point, what type of expectations from the customer coming in terms of the quality level they are expecting, in terms of the quantity, in terms of the frequency, how frequently they are buying, in terms of the variety they are buying, they are looking for, in terms of the innovation in the product they are looking for, in terms of the delivery they are looking for, right? Either they are looking for doorstep delivery, or they are looking for some pickup locations, or they want to feel the product and then they want to purchase that product, right? So, and this is not only the end, then customer expectation in terms of returns, how you will manage those returns, right? Or in terms of if end of life of that product, how you are recycling, reusing, remanufacturing that product, right? The final component is the distribution, how you are ensuring the distribution network, right? Either the last mile delivery, then last mile delivery, then how you will combine, consolidate multiple orders from the same location, or maybe sometimes what is happening when you are not so efficient with your information, then the same Amazon, if you are placed 2-3 different orders, so maybe the delivery person, different delivery person, they are making multiple visits to your doorstep instead of consolidating into one order, and then that cost can be reduced. But you have experienced that as a customer, that from Amazon morning to evening you are receiving sometimes multiple deliveries. So why can't they consolidate all the orders and then deliver at one time, right? But there may be then challenges with that, maybe customer wants some products before 10 o'clock in the morning, related to maybe breakfast or kind of things, right, grocery products, or some products maybe anywhere during that day you can transport or deliver, right. So then you need to manage, means you need to model those factors in your this modeling analysis, right. So already I talked about all these components in detail. So significance of supply chain modeling, first is you need to, this is the ultimate aim, we need to minimize the cost but maximizing the services, right. So how efficiently we can ensure the flow of those three basic components, material is one, information is another one, how efficiently we can ensure the flow of finance, right. Planning and controlling of the flow of these resources, right, we need to plan. Supply chain modeling, now once you worked with all those 8 components, now you have developed the matrix for all those 8 components, now you will go for modeling that. You will put all those constraints, these are the capacity limitations, these are the requirements from the customer, this is the capacity of our capability of our supply chain, then you will go for that modeling. And then again I was talking about experimentation and scenario analysis, where you will come up with different simulation models, different scenarios you will simulate, and then depending upon different scenarios, what is the output, either you are cost efficient or responsive, how you are making the trade off between cost efficient and responsiveness. And types of model, you can pick linear programming, where we are defining the linear relationship, that is the basic assumption of linear programming, we are defining the linear relationship between the all those independent variables, right. So whatever we are modeling in that particular model, and we go for simulation, where we are depicting different scenarios. Queuing model, what is the this also we are considering how many orders are in queue, what is the queue length, idle waiting time, so right, processing time, all that will consider in queuing model. Statistical model, different statistical model, either you talk about stochastic model, you talk about non-probabilistic model, deterministic models, right. So those models we can work with in operation research. We have seen all those models, like when we talked about transportation management, this we will discuss in our this lecture always, right. So that is part of your supply chain management, transportation. Then assignment models, we talk about simplex method, we talk about the project management using different probabilistic models like critical path method and program evaluation and review techniques. So those all are different types of modeling techniques, kind of methods which we can use to optimize our processes, right. So selecting the right model, depending upon the your requirements, you will pick the right model in the end. So these are different types of model. We will just quickly go through what are these different types of model, and in that way which model is a best fit for a particular kind of industry. If you talk about continuous type of model, this is a kind of model where continuously your product is flowing through the supply chain, not only product, information and your money, right, your finance, these three are continuously flowing. When you can ensure the continuous flow of these resources? Obviously when you are having fixed kind of demand and fixed supply, right, you are pretty sure about your forecasting process, your demand function and your supply function. So in that way it should be a continuous kind of model, right. So material should flow continuously from the supplier to customer. But what should be the objective? Okay, first we will take the examples for this continuous kind of model. Already we talked about so many, all the industries related to commodity kind of product. You talk about grocery item, usually continuous kind of model we can go for, right, or maybe FMCG products, many products we can use continuous kind of model. Steel industry, continuously we are producing. Sugar industry, salt industry, these are the best example, because as per the population we can fix this is going to be the demand and we can go for that, right. So this is these are some of the examples. Now when you are saying you are sure with the demand and supply, so obviously the ultimate objective should be you should be very, very efficient, right. So because otherwise what is there to compete? The first thing is how efficiently, how with the minimum cost you are providing that product or services, right. So, that should be the ultimate objective of your continuous kind of production system. Other characteristics, just in time we can implement because we are sure about the demand and supply. So, we can just get the supplies, continuously feed those supplies to the production lines, and right, we in that way we can reduce the inventory and inventory cost as well, and waste also can be eliminated, because now that waste which was we were generating earlier from the inventory while handling, managing, updating the inventory, we were damaging the products in the inventory only, sometime product were going obsolete. So, that waste we can reduce, right. So, it is kind of smooth flow, one piece flow kind of production system, it is coming from one end, leaving the other end. So, that is there. Advantages, all those advantages, we can minimize the cost, we can be more efficient in that way, productivity will be improved, right. Disadvantages, basic disadvantage of continuous system is less flexible, because we are not considering the dynamism of the environment, because it is a continuous model, and any disruption, major disruption will interrupt the supplies sometimes, will interrupt the demand sometimes, right. So, that is the basic disadvantage. If we will talk about the Amazon, they usually focus on this where a type of model where they are continuously sourcing the product from the sellers and delivering the products at the minimum cost, right. So, you can see this model is suitable for those business, already I talked about the examples where you have stable demand and supply. You can see this is the standard shipping where you were placing the order, but your fulfillment center is far away, then they are using some USP services to transport that product, and finally here you are where you were getting the product, right. Now, the concept is same day delivery, when you are your fulfillment center is very near to your customer, that is what I discussed in the initial slides, right. But then if you are near to the customer, you are adding more responsiveness, right. But in that way cost efficiency will not be there, because so many locations will be there, you need to serve all those locations, you are maintaining inventory at all those locations. So, inventory cost will get high, but outbound logistics you will reduce, right, and in that way somewhere you can manage in that model which you want type of product, and then your customer is ready to take. Same day delivery, then we cannot separate these two things at two different centers. Why to make multiple stoppage, right. So, then it is ultimately adding to the cost. So, why don't we do this in one station, and then crowdsourcing means local courier partners we can pick who are frequently delivering here and there, and we can collaborate with them, and finally within same day delivery or 1 hour delivery you can go for. Second is fast model. Obviously, the speed is the main parameter of this, and where you need quick delivery and timely response, and Zara is the best example where they are not only quickly delivering the product, but they are replenishing the new inventories with the old inventory, right. So, we have discussed one case where the new trends, whatever new fashion they are coming with, the average of that industry is 6 to 7 weeks, but Zara is almost every other week they are changing the trends, they are coming up with the new products, right. So, this fast model is best fit for those product which is having very limited life cycle, right. If you are talking about entertainment industry, if today any movie or web series is launched, it should be distributed fully wherever you want to distribute, right. It should not happen that now today you are launching it somewhere in the north, then you are going to south, eastern part, west, this cannot happen, right. So, these kind of products which got very limited shelf life, you need to distribute using your fast model, right. So, and seasonal products also, because those products may be for 4 or 5 months season. So, within that time you need to ensure the raw material acquisition, production and final consumption as well within those 4 or 5 months, right. Then we talk about efficient supply chain model. So, this is again we can extend the first model which was your continuous flow model, we can relate it with that, because here also we target a type of supply chain model which is which can minimize the cost, right. This is the only thing we are adding here, efficiency, right. So when you are sure about the demand, you are sure about the supply, only thing the fight is how efficiently you can deliver the product to the end customer from the suppliers, right. So that should be the priority. So you can see here we keep priority on efficient inventory management and getting the most out of production workers and equipment, right, so that the productivity can be improved. With minimum outputs you can get the maximum output, right. With minimum inputs you will get the maximum output. This is how you can increase the productivity. So this is efficient model. Obviously the challenges are there to the efficient model, because you cannot change the cost of the raw material and commodities whatever you are using, and then capacity constraints are also there. Maybe 24 hours into 7 you are running your plant, even then you cannot manufacture more than 50 lakh units. So then how you can deal with that capacity constraint? Shall we come up with a new machine or new plant? Then again, can we utilize that full capacity of the new machine, right? And some other challenges, labor shortage, delays are there, right? So highly competitive sectors are the reasons why we need, where almost products are similar kind of thing, features you are providing. So it becomes very, very important that you provide efficiently with the minimum cost. That can become your one USP, with the minimum cost you are providing the products to the customer. So Zara, we can go, this is the best example, is suiting for different cases. You see, when we have very short lead time, this is the only lead time, right. If you will see, lead time is on y axis. So we should source from the local markets like Spain, Portugal or Morocco, right. So that it can be shipped quickly, right. So items with high fashion components, means which you are changing very frequently, you need to ship immediately, you have limited lead time. Items with reasonable lead time, you can go for offshoring, but nearby offshoring, because that much time is not there. Maybe compared to this it is little higher, but still we need to go for minimum maybe distance, whatever we can manage up to that point, and we can be, those location can be some way cost efficient location, or maybe some extra advantage we are getting out of that location in terms of technology, in terms of skills we are getting, in terms of the cost, those can be there, right. If we are having that much lead time, little higher lead time, so then we can go for low cost country like China, India, where we can get the cheap labor, where we can get the cheap resources, right, all those resources, and we are producing some raw material silk also there. And then we have when more time, all the time, and then you can go for highly standardized kind of items, and you can go anywhere in the world, wherever you are finding the best locations in terms of quality, cost, availability of raw material, availability of manpower, skills, technology, whatever is required. So then you can permanently source those products to those countries, right. So this is the best example you can understand. Agile model, next is where you are responsive to quickly adapt the changes in the market. So Nike is doing it beautifully. Any changes are coming or recommendation are coming from the customer, they are quickly amending the product, right. So agile model works on how quickly you are responding to the customer, any changes in the scenario. How that can happen? When your communication and collaboration network is very strong, that any change is here, you are you are sharing immediately with your supply chain stakeholders, right. So you can see agile kind of supply chain is required when you are dealing with those kind of products where you are not sure about the demand, where everyday innovation is happening with the product or process, right. So in that way, the 4 characteristics are: you need to align your process, virtual integration with all the stakeholders and all the activities throughout the network, a network waste should be there, and market sensitivity. You need to sense the market trends, and then you can come up with that plan, right. So this can be only, I told you, agile model is only possible when you are jointly managing with your suppliers. So how supplier can manage the inventory at some point of time, right? It's not only the manufacturer responsibility. And then if you are changing the product design, process design, accordingly your suppliers need to supply the material. Custom configured model, where we are providing the customizing services, right? Supply chain according to the specific customer needs. So this is the best example. Always we talk about Dell, where you go to Dell showroom, you tell your specifications in terms of processor you want, in terms of RAM, ROM capacity, storage, speed, processing speed you want, which generation, so processor you want, all those requirements you can give, and then through their customer configured model, they will provide you that product, right? And how they are doing that, it combines agile and continuous flow methodology, right? So they are buying all the raw material components from the various part of the world, usually from the Asian countries, and then they are, as per the configuration you are giving, they are assembling the product and providing you. So this is direct kind of supply chain. Flexible model, again kind of agile model, flexibility, where you are dealing with the varying customer demands. Anytime you need to change, that should be incorporated throughout your supply chain. So part segmentation, precise stocking algorithms and flexible planning are some of the main components when you are talking about the flexible model. So you cannot go for huge pile of inventory and then you are consuming slowly in the market. Maybe tomorrow's scenario will be different, and then you require another set of raw material, another set of inventory. So then how you will ensure the consumption of the inventory already you acquired? So that flexible model doesn't work for those kind of items, right? And it's a kind of you need to turn it on, turn it off kind of thing, and Hewlett Packard is the best example for this kind of flexible model, where they are sensing the market conditions and recording the customer preferences so frequently and providing the flexible supply chain solutions, right? Another is your virtual supply chain model, right, which is, you can consider the future supply chain model as well, where we are taking the help of cloud computing and data analysis. So AI, IoT system will be part of this. The only purpose here is we have the greater visibility and communication. The things I was talking about to be more efficient, quick, agile, flexible, what you need? You need to share information quickly, and Procter and Gamble, they are doing this, they are sharing the information quickly and managing the minimum inventories, right, in that way, because only when product is required they are shipping that product, right? So best practices for supply chain modeling, you need to understand the business needs. Already we talked about different products require different types of supply chain. If you are talking about steel industry, continuous flow, efficient supply chain. If you are talking about healthcare, emergency supply chain, you need to go with an agile and flexible supply chain. Disaster management, that's entertainment kind of supply chain, you need that quick supply chain, speedy supply chain, right? Choose appropriate approach. So you need to pick the modeling method approach, how you will model those factors whatever you have figured out, right, and validate with the accurate data. So it's not only once you pick the model it will be forever. You need to validate the established model again and again, right, and you need to test all the scenarios. What if that happens, right? What if it will go the other way? We thought maybe in this way, and some other factors came into picture, we did not model those factors, and now playing very important part, right? So then we can consider different models. Obviously we can involve the stakeholders. Whatever model, if you are going for agile kind of model, you need to take the views from your stakeholders whether they are ready for that kind of flexible, agile, quick model or not. Regularly you need to update and refine that model, right? Already I talked about. Document assumptions. See, whenever you are developing any model, there are limitations. Like we talked about linear programming, and then we said that the independent variables are having linear relationship. If you are talking about simplex method, right, where we are, or transportation method, where we are talking about the linear relationship, right? So if those assumptions you are forgetting when you are implementing, then your model will be, then it will be a disaster, right? So you need to train and educate the people how they can use the best model, and those best model can be tracked against the set of performance measures you have already defined. Obviously we have some challenges because complex relationships, different stakeholders, different activities, it is very difficult to configure all those activities in one model, but still we are trying to cope up with that and define those 8 components so that we can include parameters from all those things, because these kind of models work only with the data. You need data to validate, right? You need data to develop those models, right? So then how accurately you are getting, timely information you are getting, so that also big challenge. Multiple objectives, because multiple organization, so one organization may be competing on responsiveness, other organization is competing on cost efficiency, so then multiple organization, multiple objectives, so that can be another challenge. Dynamic environment, this because dynamic modeling is required, where everyday situation is changing, you need to change your model as well. Integration issues are there because multi-tier supply chains are there and various stakeholders are there, so then sometimes those conflicts can be there, whether we want cost efficient, we want responsiveness, we want to manage inventory where the customer, we should keep inventory centralized, so those issues can be sometimes making decisions can be little difficult. Resource constraints, always we are working with the limited resources in terms of all the resources, time, money, machine, method, material, whatever we are using. Scenario complexity, because these days we have multi-echelon networks and omni-channel distribution. Multi-echelon network, where we are providing the distribution, multiple distribution points from the distributor end or supplier end to the customer. Omni-channel distribution, where the customer can come from the multiple channels, right? Like you can book air ticket through GoVivo, through Make My Trip, through Ixigo, through your IRCTC, through the Indigo website or Vistara Air, whatever airlines you are picking, right? So that scenario complexity is there. Risk management, obviously because you are working in the dynamic environment, and that any change either in all those pastoral dimension, political, ethical, legal, technological, social, all those environmental, any change in that environment will disrupt your supply chain, and how quickly you will manage that change and how efficiently you will manage, that will help you, change management. This is the future of modeling, supply chain control towers. Now this is the combination of machine learning, artificial intelligence, IoT, because now we were talking about 8 components and we have seen under manufacturing so many components can be there. So many model we are manufacturing within those production lines. On one assembly we are making multiple models, then we are keeping the inventory for each model, each component, packaging, distributing, so many different parameters. How you will keep the track of all those parameters? Then we need these cloud based solutions, supply chain control towers, which will take care of every parameter. You need information related to warehousing, whatever parameters you will say, we will see in the next session what are the different parameters when we will talk about transportation, facility, inventory. So all those parameters you just say, and supply chain control tower will track those parameters, will give you the data. Now you feed that data in your model and you will get the output, right? So if you will travel from here to the other point, so how much cost will be there, how much lead time is required, when the end time delivery will happen, and all those things you can figure out. So this is a small video on the smart solution. We'll just go through this video. So you can just see that these supply chain control towers, because when we are talking about different types of mathematical modeling we will go for, we need data for all those parameters, whatever you have set for transportation, right, per unit shipment cost, right, per unit manufacturing cost, warehouse capacity utilization, different parameters we are recording. So this supply chain control tower will help you to record all those parameters, and then you can develop your best fit model, which model is best for your type of product, right? So quickly we'll go through the case studies. First case study is about Intel, who is the largest manufacturer of computer chips. The problem here I am highlighting how they became more efficient, right? Earlier they were producing chips, and that chip were costing around $100, right? So they were spending almost $5.5 per chip for transportation, supply chain cost, right? But now because they are coming up with the new chips, and it is a low cost atom chip, so which cost around $20. So if it is costing $20 and the shipment supply chain cost is still 5.5, that is big question. So then what can be done? So they analyzed all the scenario, and they came up with the discussion that inventory is something which we can, finally reduce the cost. But why before inventory? They worked with, packaging. They scaled down the level of the packaging required for that, so that high value to weight ratio can be maintained, packaging material can be reduced. Already they did that, right? But still the cost was around $5.5 per chip, right? They already worked with the distribution cost, and they know that now further it cannot be reduced. So only thing is we can reduce the inventory, and there we can save that cost, right? So but to reduce the inventory, the basic problem was 9-week order cycle. If today you will place the order, after 9 weeks you will get the order. So that means minimum 9 to 10 weeks inventory you will keep that. So first point, while in reducing the inventory cost, how we can bring this cycle time down, maybe somewhere 2 to 3 weeks. So then we will maintain inventory only for 2 to 3 weeks. So then they thought that okay, we will go for make to order. Once we will get the order, only then we will make that, right? This is one approach they opted for. And then they, instead of cutting the chip assembly test window from 5-day schedule to bi-weekly 2-day schedule, right? So 3 days they cut there, and then they analyzed very frequently and minutely their sales and operation planning, right? So how their sales is happening, that throughput rate, how the end sale is happening in the market, right? Accordingly they planned the production, and then they asked their vendors, you keep the inventory, we don't want to keep the inventory. So this is how they worked on these 2-3 parameters, and then you can see they reduced $4 per unit for that atom chip, which was costing them 20, and you can just imagine the saving they have done just working on the inventory. But minimizing the inventory again have some challenges, right? So if you are minimizing the inventory, that means the production schedules are very, very tight schedules, means small orders you are producing. So we already know that if you are producing in small orders, production cost will be higher because economies of scale. Then transportation, if you are shipping small orders, full capacity may not be utilized. Then again economies of scale, right, will be in question. But yes, then that's why we have this mathematical modeling system. We'll keep our data, feed our data, and we'll get the best result, because you cannot count on fingers, this is best in this case, this is better in this case, this is, so that we cannot do that. So let us feed all the data in that system and we can go for that. Another quickly case of pharmaceutical industry, and you know that pharmaceutical industry, everyday scenario where acquisitions are happening and divestment studies are happening every day. So this is one organization which is expanding by venturing with other organization and keeping out their known core businesses, and that known core business is is your distribution network. And then they suddenly realized, okay, this is going very inefficient, right, and fragmented way. We need to organize this, how we can reduce cost, enhance customer services, and establish a reusable modeling tool which can automatically model the scenario and will give you the best option. So we are doing fairly well with the manufacturing, as that is our core business activity, but we need to work on the distribution network, right? So they used mixed integer linear programming problem, where they've modeled all those factors which were required, like manufacturing sites, how many sites, where the location they will decide, distribution centers, again location, how many required, demand, from which region demand is coming, what are the demand pattern, aggregated product groups, right? So they included all those products, and then they included the global as well as your local business levels, right? So then they model that, and you can see the result indicated significant improvement and 10% reduction in the overall cost, and in next day delivery they ensured in 95% of the products, right. Just working on their distribution network, how they can model using mixed integer your linear programming model, right, where they fed all this data and then they reduce the overall cost. So despite this, because obviously when we are talking about linear programming and all that, getting data from different sources, different stakeholders, and then then you are so frequently recommending the changes, and we are as a human being, we are first we are resisting to the change. So that is one challenge, and other challenges in terms of how you will take care of the data coming from different stakeholders, different activities, right. So then you have to make the trade off, right. So decision makers to understand trade offs and make informed decisions. You can make informed decision when you have that information, which is you can easily record through your supply chain towers, right. So we can conclude that modeling system will help you to simulate all the different scenarios, what can be different outputs, what are the possibility of getting the success or failure, and how the environment will behave, all the environmental factors you can model into that, right. So this is particular thing, but then you need to feed regular data. It's not one time fixed model, regularly you need to feed the data. From where you can get that data? Already we talked about your supply chain tower, solution control tower, where the virtual world is there for all the physical items you have, right. So anywhere you are depleting inventory, it can record quickly, right. Anywhere you are damaging the product, it can be quickly replenished, it can be shared throughout the network. Any customer complaint is coming because of any defect, can be quickly shared with the manufacturing process, right. So with this we'll end this, that this modeling system will help you to improve the efficiency as well as the responsiveness of the overall supply chain. So these are the references for further reading. So that's all. Thank you very much.